All righty. I'm trying something a little different here. I'm putting the computer up a little higher, and hopefully some of the work that I do sometimes doesn't show up because I don't reposition the camera. So I'm hoping this takes care of that. This video is hopefully going to help folks see the numerics involved in implicit differentiation. I'm going to try to keep it as simple as possible. I'm going to look at the simplest implicit differentiation problem I can think of, analyze it, hopefully a 10-minute video here, something that you can refer to and sink your teeth into a little numerically. And we'll have at it right now. All right, so I think you can see everything I've written so far. So let's start with x squared plus y squared equals 25, which you've studied in previous classes. Obviously, it's a circular relationship, and we're looking at a couple of numbers whose squares add up to 25, and the 3, 4, 5 triangle is probably the easiest one to look at. And so I'm putting it on an axis here where we've got an x squared, a y squared equals 25, and obviously what happens here is as the x squared gets bigger, then the y squared has to get smaller because this is a constant amount, the largest square. And so whenever you're working with Pythagoras, I would hope you would get away from working with a squared plus b squared equals c squared, which is kind of a symbolic look at the relationship. And I would hope you'd have a picture in your head so that if you had, for instance, something with a 4, and let's make this an 8, right? So you've got 16 units of area, you've got 64 units of area. Obviously, this one over here has got to be, I'm reconfiguring the triangle, 64 minus 60, 48. And so the missing amount over here is the square root of 48. It's much easier to picture the Pythagorean relationship and work with it than to work with it symbolically, all right? All right, so that's kind of just a rehashing of stuff you studied in Algebra 1, Algebra 2, and Pre-Cal. Now let's go and start talking about calculus here. So if we were going to implicitly find y prime, the first step is really all about the differentials, dx and dy. So here we have a 3 by 3, a 3 by 3 square. Over here we have a 4 by 4 square. I think I'll put the 4 there and the 4 there. So how does this change? And we studied, this is what we did day 1 in this class. We talked about, all right, let's approximate the change as this gets bigger, right? And you get these two areas, right? Well, actually 3, right? But that one there is so small we ignore it. We talked about this, numerous times already in the first 3 weeks of study. All right, so I'm going to increase the side length by 0.0001. And, squaring it is 9.00060001. So there's your 3, there's your 3, here's your 0.0001, right? And if I multiply that, I get 0.003 here, I get 0.0003 here, and I also get the same amount here, right? So that means that if the rate of change, if the rates of change of these geometric situations add up to 0, this isn't changing, then the top is going up by positive 0.0003. I mean, I can divide by 2 here, right, to make this just looking at the top layers. So this becomes x dx, this becomes y dy, and this is still 0, dividing everything by 2. Right, so I'm not looking at both layers, I'm just looking at the top layer. So over here, if this goes up by that, then this has to decrease by the same amount in order for this to add up to no change at all, right? And we know that this is 4. This is your dy. All right, so now let's go over here and let's see, you can still see I've written a bunch of this prior to starting this video. So again, x squared plus y squared equals 25, dx, 2x dx plus 2y dy equals 0. I've divided by 2, it brings us to this point in time. Now let's change the symbols to the actual numeric situation that I've produced over here. So we have a side length of 3. We have a dx of 0.0001. We have a y of 4. This is the only unknown in this equation right now, which means I can find dy. So 4 dy is equal to minus 0.0003. I've done the multiplication and I moved it to the other side. So therefore dy is equal to minus 0.0003 divided by 4. Let's actually do the old-fashioned division here. 4 goes into minus 0.0003. We end up with minus 0.0000, add another one, 7, 5, right? 4 goes into 30, right? 7 times 4, 28, half of 4 gets you to 30. So minus 0.000075. Now, that's your dy, minus 0.000075. That's equal to dy. I'm going to divide it by dx now. I'm going to divide it by dx, and our dx, we're using 0.0001 as kind of an approximation of the thought process. So that's 0.0001. And what I've done, again, is I'm looking at this layer has to offset that addition in order to equal no change. Okay, now let's actually look at this. Let's cancel that 0, that 0, that 0, that, oh, I lost track of where I was. Oh, God. Okay. Negative 0.75 to 1 is where I should have been. All right. And what's another way of writing negative 0.75 to 1? If I'm not mistaken, that's negative 3/4. Negative 3/4. So dy dx, coming back over here, dy dx is equal to negative 3/4. Looking at our final answer and the x's and the y's that we started with, that looks like there might be a relationship there. That might be a relationship. Well, let's go back over here at this line of work and let's solve for dy dx. Sure looks like I can move, let's see, what's the best way? Again, dividing by 2. I guess I'm going to do a little erasing now. I'm going to divide by 2. Let's go the old-fashioned route, right? Let's divide everything by dx. So there's dx, there's dx, there's dx, right? That doesn't algebraically change anything. This is still equal. Obviously, the dx's cancel, and I get 2x plus 2y dy equals 0. dy dx, excuse me. Okay? So now let's go back to the original. X squared plus y squared equals 25. All right? And I'm going to call dy dx y prime. That line of work should look familiar to you, given the fact we've practiced it for the last couple of days. All right? That should look familiar. And so, yeah, I guess I'm going to have to work downward here. So dividing by 2 gets us x plus y prime equals 0. Sure looks like I can take positive x on this side, move it to this side, it becomes minus x. And it sure looks like multiplication by y can become division by y. And it looks like I have y prime, my change in y over my change in x, is a proportional situation. Minus x, y. Why is the minus there? One goes up, the other's got to go down. So there's this increasing, decreasing situation. So that explains the minus. And you know, this is really, I have to take 3/4 of this number. I got to take 3/4 of that number to get it to be that amount, right? So there's this, I wish I could say that more clearly or thought about that a little bit more before I got to that moment of explanation. But that is the problem done implicitly. Now I'm going to do it explicitly for you and look at that answer. The final step, all right, is to look at that. All right, so before computers and calculators got stronger, when we wanted to graph using the early TI calculators that came out, we would look at x squared plus y squared equals 25. And if we wanted to graph this on the calculators, we have to write this as functions. So I'm going to solve for y right now. So y squared equals 25 minus x squared, and y is equal to plus or minus the square. People always forget the plus minus, unless you really push it. 25 minus x squared. So I have two graphs here. One is the positive, and one is the negative. And we used to have to put these in y1 and y2 of our calculators. This would get the top half of the circle. This one here would get the bottom half. Okay? We are looking at 3/4 right here. And what we just found out is if we drew a tangent, then that slope was minus x over y, in this case, minus 3/4. That would be the slope of that tangent line. All right? Now, let me get my eraser. And I want to look at the top half. Okay, so I'm going to simply look at y is equal to square root of 25 minus x squared. Now, I've asked you to memorize how to take the derivative of the square root of f of x. Okay, and I know I had 4 or 5 people last night at Math Help, and I thought we did enough of that I'm thinking they probably know how to do that now. So y prime is simply equal to f prime, no, y prime, excuse me, I'm saying y prime, oh yeah, f of x. So it's f prime of x divided by 2 times the square root of f of x. That's the memorization form you should use for taking a derivative of a square root. So what is the derivative of this? What is y prime? It's the derivative of what's inside, which is minus 2x, over 2 times the square root of 25 minus x squared. Well, let's do a little algebra. I think we can safely say that a moment ago, implicitly, we ended up at minus x over y, if I'm not mistaken, minus x over y. Well, looks like we got minus x when we divide the 2's out of the problem. Looks like we got that. And what is another name for square root of 25 minus x squared? Boy, I think there's another name for it over here. And if you said y, you'd be right. That's the same as that. This is explicit differentiation. This is implicit. Okay? All right, so there's a little feel for the numbers. It's the simplest situation I could think of. Again, it's the first time I made this video, so repetition's my friend. I suppose if I, went through this 3 or 4 times, I'd probably say it more clearly, and hopefully I might express it a little better, so that it wouldn't feel quite so rushed. But we're on a trimester model. I'm trying to get something out there that will help you. All right, so I'll stop the video there, and feel free to ask questions about it in class. But now some of these terms, I hope these dy terms have a little more meaning geometrically, given what we did there before. Okay, see you in class soon.